Okay, hi. I wanted to share a little bit of the work that I've done. This is my own research that I've done as part of my PhD. At the end of my rotation period, which just ended about a month ago, I chose a lab and I matriculated into the Purdy lab, which studies human cytomegalovirus and metabolism. For the duration of my PhD, that's what I will be studying. This was a project that I'd worked on during that rotation, and this is looking at a de novo synthesis pathway for phosphatidylcholine. Just a little bit of background on what CMV is. Human cytomegalovirus, also can be referred to as CMV. It's a large double-stranded DNA virus. In the cartoon on the right, it's depicted here with a lipid envelope, which it derives from the host lipids. And there's a large portion of the population, somewhere between 40 to 90% of the world's population, depending on the SES and geographic regions of the world that can vary. But the point is there's a lot of people that carry this virus, and typically it doesn't cause any disease. It's asymptomatic infection. However, there are a number of cases, for example, congenital birth. It's a leading cause of disease in newborns and infants. It's a high source of morbidity and mortality of people who are on immunosuppressants. So if you receive an organ through an organ transplant and they put you on drugs, you become susceptible to these infections. And so currently there is no vaccine for this virus, and there are very limited antivirals which we can treat it with. And so that's sort of the clinical relevance of why this is still studied today. So as with any virus, it has to manipulate its host to get it to make and do the things that it needs to do. So for this example, I have here supporting viral replication, and part of that is the fact that it lacks metabolic pathways. And so it has to get the host to replicate its genome, but also in addition to that, what we're interested in the Purdy lab is lipid metabolism. And so CMV does not encode a full metabolic pathway for lipid synthesis. And it needs that again for that viral envelope, which it buds off the host cell with. And one of the phospholipids that are embedded in that envelope is phosphatidylcholine. And so to remind you of what a phospholipid and specifically phosphatidylcholine looks like, this is a choline head group attached to a phosphate, attached to a common glycerol backbone. And then on the end here, we have two fatty acid tails, which can be saturated or unsaturated. So the evidence or the piece of work that brought me to my part of the project here came from another graduate student in the lab named Yu Cheng, and she was looking at PC lipid abundance in CMV infection. And so what you're seeing here on the left is a heat map of CMV infected cells, and these are all different lipid species of different carbon lengths. So up here we start at 28 carbon and it ends at 48 carbons. And so the way you read this here, this heat map, the red is an increased fold change in abundance of this lipid, whereas the blue is a 1/8 at the far end of that spectrum. It's 1/8 decrease, or sorry, it's 1/8 fold change. So you can think of it as being down, not down regulated, but not as highly abundant. Whereas these are like 8-fold change higher abundance. This is 1/8 fold change abundance. And so this is kind of an interesting find that some of these longer chain PCs have been highly induced in CMV infection. It's not really known why or where they're coming from exactly, but one of the suspicions is that maybe this viral factor, UL37 exon 1, may play a role in inducing these PC synthesis. But that still leaves the question of where they're coming from. There's multiple pathways which lead to phosphatidylcholine synthesis. So for my project, given the short time, we chose the shortest pathway here, which was the de novo pathway of phosphatidylcholine synthesis. What that looks like is you have choline, which goes through an enzymatic step here to phosphocholine, to CDP choline, and then finally to phosphatidylcholine. And so the hypothesis then for my project was that cytomegalovirus induces this de novo pathway over here of phosphatidylcholine during infection. So to put things in a broader context, over here, this is a pathway coming off of glycolysis, which would lead into making phosphatidylcholine a separate way. Alternatively, you can come up through this phosphatidylethynolamine pathway and make them that way. The de novo pathway comes in right here, and that end product being this molecule, phosphatidylcholine. So the approach that we used to answer the question of my project was CMV inducing this pathway was to use these choline head groups, which were labeled. And so if you think back to your chemistry from college or high school, you might recall that 99% of carbon exists as a 12 isotopic carbon. So it has 6 neutrons and 6 protons, and those two together, the atomic mass unit of those two would equal the 12 isotope. However, there is a small portion of carbon that exists as a 13 isotope, and so that means it has 1 additional neutron packed into its nucleus. And so what that allows us to do then is using highly sensitive equipment like a mass spectrometer, we can then detect that 1 AMU shift in molecular mass. And so what we did was we purchased these choline head groups, which I have boxed off over here. And these contain 2 carbons, which are of the 13 isotope. And so when we view this on the mass spectrometer, compared to a normal choline head group, these are 2 AMU heavier, I guess you could say. The atomic mass molecular weight is 2 AMU heavier. And that's enough for that machine to pick that up. And so what this allows us to do then is to feed the cells with this head group, and this would only come in through this pathway. And that allows us to say, does the virus induce this pathway any more than if it was not infected? So I took human foreskin fibroblasts and I infected them at an MOI of 1 with cytomegalovirus. And in both the mock infected, so those are cells which did not receive virus, they just received water. And in my virus-infected cells, I fed them these 13 choline head groups. And I let that go for 72 hours, and every 24 hours, I scraped the cells out of the dish, and I fractionated the lipid membranes, and I collected that and performed mass spectrometry on those lipids. And so looking at the data here, this is just an example of what I found. Across the x-axis, you see time. These are the 3 different time points. And then this y-axis is a readout of the fraction of 2 labeled. So this is the percentage of any one particular species that had 2 labeled that shift of 2 13 carbons incorporated. Now, I mentioned that naturally occurs and it's at a really low abundance. And at that point, we would only see 1 labeled. We would see 1 addition of a carbon. So this pretty much tells us that if we're seeing 2 13 carbons appearing on our molecule, then we're fairly certain, we're fairly confident that it's because it's on that head group. And again, that head group, if it's being induced in CMV infection, that would be really interesting. So to orient you to what you have here, the red is the infected cells, the black would be the uninfected cells. And these are just 2 examples of 2 lipid species. This is a 32 carbon chain, and this is the uninfected and the infected. And we have a 44 carbon with 5 double bonds in the uninfected and infected. And so what we see here then is that in our infected cells, we do in fact see this increased abundance of both of these lipids in the infected cells. So this is one way that we're measuring here then that during CMV infection, these 2 lipid species were produced more through that de novo pathway than the uninfected cells. And so that's kind of an interesting and curious finding. However, it wasn't just these 2 lipids. I looked at a number of lipids. And so in this graph, you're seeing every single line represents a lipid, and this is the mock, and this is the infected. And what we saw was that in every lipid species, these were upregulated, or rather, I shouldn't say upregulated, they were in greater abundance in the infected cells when compared to mock. And so that's a really interesting find. We're not sure what that means, but moving forward, that's something we would like to try to tease out. So looking at this data in a slightly different way, this is a bar graph just showing on the y-axis that same fraction. This line here represents 50% of that lipid species. And what we see is in the infected cells, we get an appreciation that these are really in greater abundance. The two labeled species are in much greater abundance than in the mock infected cells. And so something's definitely happening. We just don't know what it is quite yet. And so my conclusion here then is that CMV infection does in fact induce this de novo PC lipid synthesis pathway. And the current model that we have and we think might be happening is there is some viral factor which acts on this pathway to increase its activity, making more PC lipids through this de novo pathway. So moving forward, asking this general question, what is the function of these PC very long chain fatty acid lipids in CMV infection? That's sort of the overarching driving question of the lab. More specifically, we would want to know, is this pathway absolutely required for CMV infection? And so my hypothesis then would be to test out that it is required, and without it, it has difficulty and problems replicating. And so the way I would approach that is to use a rate-limiting enzyme right here, this CCT alpha. This goes this is the enzymatic step between choline or phosphocholine and CDP choline. This is what we call the rate-limiting step. And I would want to knock this enzyme down and see what happens then to the pathway and to the virus then at that point, and find out, does it need this to survive? You'd want to measure replication. Some other questions then, what are the viral mechanisms responsible for enhancing this? I have a hypothesis then that the virus does induce this in some way, and there's a couple targets that we have. These are viral proteins which may be contributing then to increasing either the transcripts or increasing the protein synthesis of that rate-limiting enzyme. And then so maybe more broadly as a final question, what other lipids then are important for CMV infection and replication? And so we would want to use mass spectrometry again. So liquid chromatography, mass spec, tandem mass spec is a tool that we use to answer these sorts of questions. And so I'm sort of interested in some of these inflammatory lipids molecules, like the arachidonic acid pathway leading to your prostaglandins. You have the leukotrienes, the lipoxins. These are all lipids which the cell releases during stressful times. And so I think it'd be interesting to look and see if CMV is doing something because this can sort of let the cell know, or other surrounding cells know, that there is an infection. So I would venture to guess that CMV has some way of stopping this from happening. And so with that, I have to thank my PI, John Purdy, his graduate student, Yu Cheng. She was a big help in this, and then the undergraduate in the lab is Max, and he was also really helpful in helping me navigate around the lab my first couple weeks there. And so, yeah, I will continue to post these as I have to put together presentations for my lab and as part of my program. So I hope you enjoyed.